Okay, so welcome back to part 2 of the video on linear regression using the Ti-Nspire. So hopefully you've now gone ahead and made an attempt at example number 3, and I'm going to explain that example to you, make sure you've got some of the mechanics correct, and let's see how you did on finding your axial intercepts, figuring out what they represent, and figuring out the domain and the range. Okay, so once again, this is the same data that we used in our very first lesson. So I've gone back on my calculator to the very first page, which has got my turnover and fouls data already entered. And so what I'm going to do now is go ahead and add a page again. I'll do it from the beginning, so we've got graphs for each of these. Data and statistics page. From the bottom, I'm selecting turnovers. Remember, we had a discussion in the first lesson that it's the turnover that causes the personal foul and not vice versa. And so that's why we put our turnovers on the x-axis. And then we have got our, where have I got it, fouls over there. So here's our scatter plot. And what we can do is, again, using the graph, we've got our analyze, regression, and show the linear function. And so that gives us our equation over there. Like I said before, the downside of this, of course, is that it doesn't treat this as a function, as in a graph on a Cartesian plane, and so that limits your ability to work with this. And so I'll just remind you of our alternative. So, of course, we could get the equation from here. Let me go ahead and make a note of that equation over here. So in this case, we have y equals, y is our dependent variable. So in this case, personal fouls are y, and turnovers are x, because x is independent. It's the turnovers which cause the fouls and not vice versa. And so what we can do is say personal fouls are equal to 1.03 multiplied by the number of turnovers plus 3.25. So that would be the regression function, our linear regression function, and now we're going to use that to answer the next couple of questions. So the first thing we've been asked to do is to find the axial intercepts. Of course, this is the x and y intercepts. And so if you look at your function over here, I'm interested in knowing where does that cut the x-axis and where does that cut the y-axis. Okay, so what we're going to do is I'm going to actually use a different graph for this. And so what I'm going to start off by doing is I'm going to redo the regression calculation. I'm just going to add a calculator page, and I'm going to do the regression calculation slightly differently. I'm going to go via the statistics menu, and what I'm going to do, what I want to do is menu, statistics, stat calculations, linear regression. My lists this time are going to be turnovers and fouls, and that's going to save as F2. So I'm going to go ahead and do that. Gives me the exact same equation, but this time what I want to do is I'm going to add a graph page, and when I scroll up, I'm going to have function F2 over there. I'm going to check F2 off, and now I have a graph of F2. I'm just going to slide that over a little bit to the left. And so if I want to find the x and y intercepts, of course, this is the x-intercept, where it cuts the x-axis. And so I'm going to go ahead and find that using the analyze graph function. And what I'm interested in is a 0. So I go to the left, to the right, and there's my 0. And then what I'm going to do is go ahead and find the y-intercept. Remember, one of the ways we did this with parabolas was to trace the graph, and then as I scroll along and get to the y-intercept, it should highlight that for me. I just hit enter, and that's one of the ways I can do that. So very quickly and easily I can find the x and the y-intercepts. Let me come over here and make a note of those. So the x-intercept occurs at minus 3.16, 0, and the y-intercept is going to occur at x equals 0, y equals 3.25. And so what we've got to do is interpret this in the context of the problem, and this is where it gets a little bit unusual. What this technically means is that in order to have 0 personal fouls, a player must have played, or a player must have turned the ball over minus 3.16 times. So the only way to have no personal fouls, according to this mathematical model, is to have turned the ball over minus 3.16 times. Now, of course, in reality, this is impossible. You can't have a negative number of turnovers, nor can you have a fraction of a turnover. You can't partly turn the ball over. And even if you could, you couldn't measure it mathematically. And so this is a good example of a limitation of a mathematical model, because it's going to produce points which in the real world have no applicable meaning. That doesn't mean the model is useless. It just means that what we have to do is be aware of the model's constraints or applicability or limits. Okay. The y-intercept in this particular case has a little more meaning, and the implication of the y-intercepts in this particular case is that if you have an x of 0, in other words, if you have 0 turnovers, then we expect you, or we predict that you will still commit 3.25 personal fouls. Okay, and again, this could be true. We could explain this. Remember, of course, you can't, you cannot commit a quarter of a personal foul, but this is, of course, a predictive value. This is another one of the limitations of a model, is that its answers might be fractions, where in reality we can only deal in integer values. So 1, 2, 3, 4, 5 personal fouls, not 3 1/4 personal fouls. But it does highlight the fact that it's possible to commit a personal foul without a turnover as well. Okay, and so we've interpreted those, the domain and the range of our model. Of course, if you consider what this represents, then a realistic domain and a realistic range would be that x, or the number of turnovers, should be greater than or equal to 0. Of course, you could have no turnovers at all, and similarly, the number of our personal fouls in this particular case would be, in the context of the model, would be everything 3.25 or above. That would be the range of our linear model. And so in this particular case, for personal fouls, we are going to say it is everything greater than or equal to 3.25. Okay, the advantage of putting this into a graph is, of course, if I now wanted to make a prediction, so if I want to use the, once I have it in a page like this as a function, it is very easy using the trace menu to type a value in, and for it to instantly substitute that value and work it out for you. And so if I wanted to type in, for instance, how many personal fouls am I expecting a player with 8 turnovers to have, then I just type in 8, hit enter, it works out the value for me, and I'm going to hit enter again. For somebody who has 8 personal fouls, we predict that, 8 turnovers, we predict that they'll have 11.5 personal fouls. Okay, and let me just make one final point, which is something that I did not highlight a little bit earlier or ask a question about, perhaps I should have, and that is the interpretation or the meaning of the slope. And so slope, remember, is change in y over change in x, and in this case, of course, change in y is change in personal fouls over turnovers. And so what this is essentially saying is that for each additional, so change in y, change in personal fouls, change in x, the slope is 1.03, which is 1.03 over 1. For each additional turnover, we are expecting, according to this mathematical model, 1.03 additional personal fouls. Okay, and so that is the significance of the slope of the line in the context of this particular problem. And so slope is very important to interpret. So each additional turnover is being met on average with 1.03 additional personal fouls. Okay, at this point what you need to do is turn your attention to the assignment, which comes from the old red textbook, and I will see you again after the spring break.